important. With that, I'm going to start with just describing our aquifer. You've seen lots of maps. It was discovered in 1894. It covers about 370 square miles in both Idaho and Washington, and touches over about 4 different counties, mostly Kootenai and Spokane. Again, just a reminder of some of the properties of our aquifer. It's unconsolidated glacial outwash materials, which you can see in this picture here at one of the gravel pits. A lot of them are coarse grain, cobbles, pebbles, sand, and there are some lenses of silt and clay that acts as aquifer limiting layers. It doesn't allow water to transmit past them. There's also metamorphic and intrusive igneous bedrock that these unconsolidated materials overlay. Our groundwater infiltrates and moves through the aquifer pretty quickly, as we have learned, and it can interact with our surface waters. So when the aquifer was designated as a sole source aquifer by the EPA in 1978, we got an initial set of funds from the Clean Water Act to do our, to start our monitoring programs on both sides of the state at the same time. And that was the start of our monitoring. The monitoring has evolved on both sides of the state line throughout the years. Currently, Spokane County is the primary entity that monitors on the Washington side. We have about 50 sites that we visit, and our sampling is somewhat is quarterly. On the Idaho side, the Panhandle Health District does most of the monitoring. Idaho Department of Environmental Quality supplements some of that with specific studies and data analysis that they're interested in. The Panhandle Health District has 33 sites, and they sample somewhat less frequently at 3 times a year. For both sides, not all sites and not all parameters are sampled quarterly or 3 times a year. There's some variation in that. So in case you haven't seen what water sampling for groundwater looks like, we use a portable pump to pump up the water from the monitoring wells, and then it gets ran through a YSI or other monitoring meter that gives us our field parameters. And once we're done with that, we disconnect the tubing and fill up bottles of water that we send to the lab for analysis. When we go to purveyor wells, which some of you allow Spokane County to monitor, we get to just turn on a tap and connect our tubing and work it that way. But this is what it looks like at a monitoring well. So our field parameters are pretty consistent on both sides of the state line. We collect depth of water, which allows us to get what the water levels are doing at those locations. We do not get this at the purveyor wells though, because there's no way for us to manually collect that data. We collect temperature, conductivity, dissolved oxygen, and pH. And a lot of these parameters are really important because they can help us identify where those surface water, groundwater interactions are occurring. For example, with temperature, groundwater that is primarily from the regional groundwater aquifer system will have relatively stable temperatures. But when you get to a river influenced well, you're going to see those seasonal fluctuations that track along with the river. Same thing with conductivity. The regional aquifer system is going to have higher conductivity because you're going to have more minerals dissolved into the water. Whereas if you get that river influence, that river is going to dilute those levels and bring conductivity down. Dissolved oxygen and pH are really important because they can influence sort of those contaminant transport type processes like redox reactions. So it's really good for us to know whether our water is anoxic or oxic and whether it's acidic or alkaline. So for our grab samples, we on both sides of the state line have a little bit of differences of what we collect. The elements that are bolded with the asterisk are collected on both sides, and then the state is identified for the other elements where it's differently collected. So major and minor ions are very important because that tells us something about the groundwater chemistry, how the groundwater evolved, what that source water is, whether it's that regional aquifer or whether it's river water that's the source water. Nutrients are really important because that is what drives plant development. Plants need both nitrate and phosphate in order to grow. But nitrate is a lot of times in water systems inputted by human activities. And the reason nitrate in this region was really important to track is our aquifer was reaching that 10 milligrams per liter maximum contaminant level that affects human health in our drinking water. So we wanted to track those levels and see if they were going down after we started sewering more locations, because a lot of that nitrate was coming from our septic systems. Phosphorus is really important to track because our Spokane River is listed as not meeting criteria for oxygen levels, and there's this connection between phosphates driving up plankton levels, and then once the plankton die, oxygen levels get consumed, go down. So they found this connection, and they're trying to limit the amount of phosphorus going into the Spokane River. And since the aquifer feeds the Spokane River in certain locations, that's why it's important to track in the groundwater. The metals, organics, and coliforms are all potentially human health concerns at certain levels. So we track those to see where they're at in the groundwater. So our data tells us that the aquifer is pretty healthy. We are not having many problems at this point after sewering and keeping track of these. So why continue to monitor for these parameters? And it's to keep it that way, right? Because right now on both sides of the state line, we're seeing large population growth, a lot of urbanization, and a lot of development. So we're going to have more demands on our water system, and there's going to be potential for more water quality impacts. Some studies done in 2010 and 2011 show that the total water demand, that includes all uses, whether it's municipal, industrial, commercial, ag, all of that, is going to increase in the next 50 years. On the Washington side, it's a little bit lower at 33% increase. And on the Idaho side, it's going to increase by 57%. And then with water quality, as land use change, you're going to have different considerations for what's going into the groundwater in terms of pollutants. A rural area might be more concerned about nutrients from septic systems or pesticides from ag, whereas when you start getting more urbanized, you're going to be thinking more of hydrocarbons, heavy metals, PCBs on the Washington side, PFAS. So you're going to have different concerns depending on what that land use is, and it's going to change. And this is just showing some examples of how drastically Spokane has changed over the last 40, 50 years. So this is a picture at the state line back in 1940 versus 2019. And this is Sullivan Road back in 1965 versus 2019. So we can visually see it, and if you grew up around here, unfortunately I did not, but my husband did, it's a large change. So even though the aquifer is pretty good in terms of water quality, we're still seeing the results of human impacts on our aquifer from our water quality data. So taking both Washington and Idaho's data, for long-term nitrate trends, trends in red is increasing, trends in green are decreasing, and the sites where it's gray, they're relatively stable. So you can tell, like, from, you know, both Idaho and Washington, the areas that are having increases in nitrates are those areas that are still served by septic systems and are pretty rural. So we're pretty still well under that 10, but if they keep increasing, we could reach those levels in these areas again. And the other thing to point out is that this light gray line here, hopefully you guys can see that. That's a flow path that was identified through modeling. And the really cool thing is when I first did this data and I didn't have the Idaho side, just had the Washington side, I was like, why are only these certain locations trending in the red? And I was clicking on all these GIS layers, trying to figure out what the connection between these areas were. And I finally found the capture zones for the wells. And then I was able to see, oh, this is how they're connected. They're all along that same flow path in that capture zone. So that was really, really cool. And then when I got the Idaho data, the fact that they all fit together just made me feel a little better about what I was seeing. So chloride is another element that we test for that can show human impacts. And right now, chloride, even though it's pretty low, right? I think the MCL for chloride is 200 milligrams per liter. We're well below that, but you can see that it's increasing everywhere throughout the aquifer, both on the Idaho and Washington side. And this is likely due to a variety of reasons. Spokane County actually did a chloride to bromide ratio analysis to kind of figure out where that source of the chloride is, and it was inconclusive. So we can't even say it's road salts, for example, but it's probably generally increasing from septic tanks, road salts, you know, anything that can release chloride into the ground. All of that's working kind of against us. So there are two sites where you can go to collect data on the aquifer. Spokane County's groundwater monitoring website has data from our program, and the Panhandle Health District has data from their program. And if we have time towards the end, which I suspect we do because I talk really fast because I get nervous, I'll show you what these look like. And so to bring this all back to modeling, it's really important for water quality managers to have this information as well as purveyors. Because like I said, you can kind of see where those trends are, how they're interlinking. You can look at if it gets integrated into the model, you can look at those particle tracking and put in like a contaminant and see where it'll go. I don't think we're planning on integrating water quality at this time for that project, but in the future it could be used in that manner. And I think that's really, really cool. So with that, I sped through really, really fast. If you have any questions, we can take them now, or you're free to call or email. I'm happy to help. So
Thank you.
yeah, and I'll go to those websites really quick. Did we stop screen sharing?
Yeah. Do you want to talk about them while I get this screen sharing?
Yeah, so this one here is the Spokane County's groundwater monitoring website, and we have a few things on here. We have PDFs of our data that you can download, and that's how they were provided to the purveyors for a really long time. But that's not always super helpful to look at in a quick and meaningful way. So we ended up
Oh, yeah, there you go.
So we ended up using this interactive Tableau database, which if you click on that and go down, you can see all of our monitoring locations. And if you're interested in a specific one, you can click on it and scroll down. Let's see. It doesn't want to go down. But down here, you can see the data for each element. And if you want to look at a specific element, you can just click off the all and say, okay, I want to look at dissolved oxygen, for example, and it'll pull that information up. And sorry, I can't get it to, maybe if I minimize it. Pull it down, you can see the DO data for that particular location. So it's pretty, I think, user-friendly, and you can find your well pretty quickly and pull up the data versus having to go through a PDF and figure out what your well code is and that sort of thing. So that's the county's website. The Panhandle Health District kind of works similarly in that you can go down here, you can click on a well location. I'm trying to remember which ones I know kind of work. So they have actively sampled and historically sampled. Like I said, we changed our programs throughout time. So historically, a lot more wells were sampled. If you click on one of these, you can pull up the data. You just have to say, okay, I want to see temperature, display graph, and if it has it, it'll put results in there. You can also put in dates. And I think everything on the Panhandle Health District is before March 2022. So you can just put in date ranges and it'll display graphs here. But that's how both websites work. And I think they're full of information that might be helpful to everyone. Questions?
Yeah, I mean, just to add to that, Jenny Gray from Panhandle Health, we have a new database, and that's why data on that website only goes through March of 2022. Our new database and our website are talking to each other well. But if you guys need data after March of 2022, just reach out to us and we can pull that directly for you. We're working on fixing that problem, but it's been a challenging one with our firewall and work in progress.
Yeah, and ours goes through 2019 because that was when we finished our 20-year report. And we'll start adding more data onto that, but we got to do some QA, QC and need some time just to update that Tableau.
Do you have any like fun facts or interesting wells or chemical data that you find in the Rathdrum Prairie Aquifer? Have you done, or any other sampling versus any other sampling you've done in non-Spokane Valley Rathdrum Prairie Aquifer wells? Like, is it really high DO? Is there anything interesting?
Well, to be honest, this is the first job I've had that's focused on groundwater. Most of my backgrounds in surface water monitoring up in Alaska. So we don't really think about groundwater there too much, although maybe at some point they will with how things are changing. So yeah, just a little bit different. Had to learn groundwater here, but our most interesting locations, just to give you an idea, if you go to the Sullivan Road, whoops. Did I? Oh, here we go. So if you go to Sullivan Road and if you're able to scroll down and look at, say, temperature or conductivity, you're going to see those seasonal fluctuations with the river because that's where the river is influencing the groundwater. So that's kind of interesting to compare to some of the other ones that are more regional. And then we have another monitoring well at Plants Ferry. That's the only well in our system where the water is acidic and anoxic. So it has a very different chemistry than all of the rest of the wells in our system. And you can see that. Another way to look at some comparisons is if you compare these two wells here, you'll see the fire station at Houston and Regal is in the upper aquifer, whereas the North Spokane Irrigation District well is in the lower aquifer below a confining layer. So those two have very different chemistries as well. So there's things that you can get on here, and if you click on both of the sites, their data will both show up, so you can do comparisons and kind of see what's going on.
Amy, I haven't been able to do it my own time, because unfortunately, I don't spend my free time looking at the Spokane side data.
Yeah.
Is it quite stark difference in those two upper and lower aquifer, the chemistry?
There's not, yeah, there's not too much. We can put them on here, and you can see if I can scroll down. Not sure. This might be easier to do on your own computer, actually.
If you can slide over to the right.
Slide over.
Yeah, are you trying to get to your key?
Well, just to scroll this down.
And are you trying to get over here?
No, it's just, this should come down and it's not. I'm not sure. It might.
No.
Oh, it'll just open up the map in a
Oh,
different
okay.
format.
Scratch that.
But yeah, it'll compare them, and it's a quick look. I don't know why it's not scrolling all the way down to show, but. No, it's,
Would that help you?
oh, maybe.
Nothing like having an audience helping.
Yeah, right. So yeah, I'm not sure what exactly is. Should be able to select both. And it's,
Oh, wow.
okay, so there's the comparison. And yeah, so it'll show you the differences. I think for this one, the connectivity is a little different just because of that confining layer provides some protection. Things aren't getting into that lower aquifer. So you can see that here, that upper aquifer has a lot higher conductivity than the lower one. So yeah.
It's very cool.
Any other questions? Yes.
Is there any discussions of expanding what you're sampling for?
Currently, no. Part of that, I know we really want to. My staff is back there like, yes, let's do it. We've had lots of conversations about that, and unfortunately, our funding mechanism is through the Aquifer Protection Area fee or tax, if you will. And that's supposed to come up for renewal at the end of 2025. 2025 is the last assessment of that fee, and if it is not renewed, we will not have a constant flow of income in order to keep our program running. And the fate of that is kind of uncertain, and well above my pay grade on how that gets handled. So right now we're just looking at for this last year, some of these parameters we haven't had hits for in a long time, like fluoride. We don't see at all in the aquifer except for in that Plants Ferry because of that anoxic acidic condition. So some of these things where we know for a long time, for those 20 years, we haven't had any detects at all. We're kind of removing them from our program so that we can continue on as is with stuff that we know that we're getting good data for.
Amy, if you had a wish list and
Oh,
you
don't
didn't
ask me
have to
that.
worry about budget, what would
I
you
might
and
get
your-
myself into trouble.
Can you share any other contaminants that you would like to see Spokane County monitor for in addition to what they're doing now?
Well, I think it might be interesting. I think historically we used to collect a lot more ions, and as I'm learning more about groundwater, I'm learning how those can identify specific groundwater chemistry and development, and I'm kind of interested in seeing what that looks like for our aquifer. And it supposedly could tell you a little bit more about what's contributing to the groundwater quality, even human-made type stuff, if you look at different ratios of all those ions with nitrate and that sort of thing. So I was thinking at the very least trying to expand some of that, for example. I also wondered if maybe we could do some snapshots with what the purveyors are already doing with some of the EPA requirements with PFAS and that sort of thing, but then that gets really political really fast. And so try to not push that too hard. But there are other things like that we don't look at that Idaho does, and I think it would be good to get a snapshot if we could kind of partner and get everything all at once. Some of those VOCs and those sort of things that are really prevalent in an urbanized area, get snapshots of those to see if there's problem areas, I think would be kind of interesting. So those were just some thoughts that I might not get in too much trouble for sharing, but
Well, oh, go ahead, Bob.
I'm just curious, partially because we have a well across Plants Ferry. How understood, or is there some working theories on why that one's acidic and we have another
yeah, so
show up in it?
yeah, so that one is actually under a confining layer as well. And so that confining layer is, if I remember correctly, much thicker than some of the other confining layers up north. And so it's really changing that chemistry. And I'm not sure how much water like is recharging that area. And we kind of use as a comparison, the well here at East Valley High School, because there's that flow path that kind of goes across that top there. And even though they're pretty far apart, we kind of think that they're probably at least in our system, the two that we can compare with each other. So I'm not sure that there's very much recharge happening just because of that confining layer, and that's why it has this. But I'm also not a hydrogeologist, and I'm just learning groundwater over the last 5 years. So that's just kind of what I suspect, is that it's just part of that lower layer chemistry that's going on.
Hey, before I let you go, I'm gonna do a little, I guess, ad, since we have some captive viewers online and here in this room, more for the Washington folks. So to continue the program with Spokane County Resources, $15 a year per household, is that about what it works out to?
I think so.
Roughly 4 cents a day to have somebody monitor and take care of our water quality. You know, how many of us probably have that in our couch cushions at home?
Just forego
over the course of the day?
Starbucks coffee.
Yeah, exactly. So we're talking $15 a year. So if there's a regulator, elected official, anyone that wants to listen, please make sure that that's on the ballot, because I think that's not something elected officials should decide. It's something that we, the citizens, should decide. And it's a very important work. And I can't thank you enough for the work that you do and your staff do for Spokane County. So
Thanks.
that's my 2 cents.
Well, I appreciate it.